Today we're going to be talking about the VSEPR Theory. And so what the VSEPR Theory is a way for us to figure out what molecules look like in real life, basically the shapes that they take on. So VSEPR stands for Valence Shell Electron Pair Repulsion. So I'll write that out for you. VSEPR stands for Valence Shell Electron Pair Repulsion. And so basically what this is saying, just through the words, is that the electrons in the valence shell, those are the ones that we are drawing in our Lewis structures, actually repel against each other since they're all negatively charged to push atoms either closer or further away from each other so that they have more room. And through that repulsion of each other, these molecules are going to make specific shapes. As it says here, you need to memorize all the molecular shapes. You have a chart that looks like this. What you have to do is you have to know the number of bonded atoms, the number of lone pairs, and the molecular shape. You should know the angles between the bonds as well. So let's start talking about this. There is a very specific procedure in order to figure out what shape a molecule is going to take. Now, when I say a molecule, I'm only talking about covalent compounds. Your covalent compounds are your molecules. So let's do a few examples, and then we'll write down some steps on how to actually do this. So my first example is CH4. You are always going to start by drawing a Lewis structure. And so we know the steps of drawing a Lewis structure. Our very first step for drawing a Lewis structure is first figure out if it's ionic or covalent. This one is a covalent compound since we are doing our molecular shapes. And then we have to figure out the number of valence electrons each atom has. So we know that carbon has 4 valence electrons. Each hydrogen has 1 valence electron, but there are 4 of them. So altogether, we're going to end up having 8 valence electrons. So we want to go ahead and draw the Lewis structure. So we know that carbon's going to be in the middle because it's by itself, and we are going to attach hydrogens to all the sides. Our next step is making sure that each atom has its octet. Carbon does need 8 electrons around it, so 2, 4, 6, 8, that is fine. And then each hydrogen only wants 2 electrons around it, so those are fine as well since they each have a bond to it. Then we have to make sure that the Lewis structure has the same number of electrons in the structure that we do valence electrons, 2, 4, 6, 8. So we're good. We have a good Lewis structure. So now to take the next step, we have to figure out the shape that it's going to be. And this is based on the number of lone pairs and bonded atoms. In order to figure this out, we need to know a few definitions. We have to know what a domain is. We have to know what a lone pair is. And we have to know what a bonded atom is. A domain is simply the number of things around the central atom. So it's always going to be the lone pairs plus bonded atoms. So it's the number of lone pairs plus the number of bonded atoms. The lone pairs are the number of paired electrons that are around the central atom. Keep in mind that we're always talking around the central atom. Okay, so this is pairs on central atom, Ca. Bonded atoms is going to be the number of atoms bonded to the central atom. Keep in mind, this is not the number of bonds. It's the number of bonded atoms. Two very different things. So, for this example, lone pairs. We do not have any lone pairs around the central atom, so this would be 0. And there are 1, 2, 3, 4 atoms bonded. So there are 4 bonded atoms. So until you have these memorized, you can look at your chart and say, All right, the first thing is bonded atoms. So I have 4 bonded atoms and no lone pairs. So that is called a tetrahedral. Now keep in mind that all of these shapes are 3-dimensional. So a tetrahedral would be the molecular shape. Another question that I could ask you is, what is the bond angle? The bond angle is the angle that is between 2 atoms. So for tetrahedral, you see that it's 109.5 degrees. This is all memorization. All right, let's try another example. ICl3. So what I want to do is first figure out the number of valence electrons. Iodine has 7, each chlorine has 7, and there are 3 of them. So that's 21 plus 7 is 28 valence electrons. Now we're going to draw iodine in the middle, and then chlorines. Then we have to make sure that each atom has an octet. So 2, 4, 6 around that chlorine. We need 6 around this chlorine, 6 around this chlorine, then 1 more lone pair around the central atom. So now each of them have their 8, so now we count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. There are 26 electrons in here, but 28 valence electrons in our formula, so that means that we have to add an additional lone pair. So now we have 28 valence electrons. Now we want to do the same process. We need to figure out the number of lone pairs that are present and the number of bonded atoms that are present. So again, I'm looking just at the central atom. There's 1, 2 lone pairs, and there are 1, 2, 3 bonded atoms. So like I said, until you have this memorized, you are more than welcome to use your chart. So I am looking for 2 lone pairs and 3 bonded atoms. So that's going to be right here. So it says, right? 3 bonded atoms, 2 lone pairs. The name of that shape is a T-shape. Now, for the bond angle, you see that it says 2 different angles. So you can write 90 degrees and 120 degrees. Let's try one more. Let's actually do this one on the whiteboard. Let's do CO2. All right, so carbon has 4 valence electrons. Oxygen has 6, and there are 2 of them. So you add this together, that's 12 plus 4, that's 16 valence electrons. So I'm going to put carbon in the middle, oxygen on either side, and then I have to start filling up my valence electrons. So oxygen needs 6 more, same thing for the other oxygen. And then carbon, right now only has 4 electrons, so it needs an additional 4. Now count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We have too many. So I'm going to take away a pair, make them share. And count again. 2, 4, 6, 8, 10, 12, 14, 16, 18. Still too many, so take away a pair, make them share. 2, 4, 6, 8, 10, 12, 14, 16. So now I'm good. All right, so now I have to do the same exact process. Figure out the number of lone pairs that I have, the number of bonded atoms that I have. Again, I'm looking at just the central atom. So there are 0 lone pairs on the central atom. And there are 2 atoms bonded to carbon. So that is 2 bonded atoms. Please make sure that you are not counting the individual bonds. You are just counting the number of atoms that are bonded to the central atom. So I have 2 bonded atoms and no lone pairs. So I'm going to go to my chart, find 2 and 0, and this is a linear shape. Okay. Now if I wanted to know the bond angle, I can see on my chart that the bond angle here is 180 degrees since it is a straight line.